Students, this is the lecture number 23, and in the last lecture I started discussing about unsupervised learning, and as a part of that we discussed about K-means algorithms. Today we will carry forward that. Even today we will redo the mathematical part which we have done in the last lecture, so that you can understand clearly. So first of all, what are unsupervised learning? So machine learning, as we have said, there are two types of learning. One is supervised learning, in which you develop predictive model based on both the input and the output. That means for every input we have a target variable known. Then we can develop some model, and these are called supervised learning. And we discussed many of them, like classification problem we discussed a lot, regression we discussed, even we have discussed ANN also. Now in comparison to that, unsupervised learning, you have only data of the input. That means you do not have data of the target or output. Then how do you model it? That is why unsupervised learning is used. And one of the major technique or algorithm of unsupervised learning is clustering. And what is clustering? This is nothing but a task of dividing data. Before we go back, remember, supervised learning is extensively utilized in alloy design, but does not mean that unsupervised learning is not used. So we will see when TS will discuss about the classes, in the classes they will take live sessions, they will give examples of this clustering, how we can cluster the data and do a machine learning modeling. Okay, so as you know, unsupervised learnings can be many types. K-means clustering, K nearest neighbors, which you have discussed already. You can have also PCA, principal component analysis, independent component analysis, ICA, and also you have techniques like a priori algorithms, singular value decompositions, which we may not be able to discuss given the time we have. But what we are going to discuss is today is the K-means clustering, some part which needs to be talked or needs to be discussed, and hierarchical clustering, and we will see how these techniques are developed. So let me first tell you what is clustering. It is nothing but a task of dividing the data with meaningful groups, and this is done based on the information of the data. You should have some information of the data, then only you can divide into meaningful groups. That is what it is. Now the question is, it is aimed at forming groups of homogeneous data. This is what is. But now the question is, how do you determine which is a homogeneous data point? And so therefore you may have a heterogeneous data set. Let us talk about, you are doing a marketing survey and going to each home, try to collect information what kind of shampoos they use. So you will get heterogeneous data sets, right, different categories of shampoos they will use. So now if you want to cluster, that which locality of a city is using which type of shampoo, that means what you are doing is basically homogeneous groups are formed from the heterogeneous set of data. That is the aim. Now there are different types of models which we will discuss today also, centroid models, which is nothing but a K-means algorithm, and connectivity models that are nothing but hierarchical models or clusterings, and you can have density models like spatial clustering or applications with noise. So let us talk about very simple way of understanding clustering, right. I give you the example. Suppose in a city of Delhi you have some dysentery outbreak, and physician in a hospital is trying to plot the location of the dysentery cases on a map, and when he or she has finished it, the data indicated that cases cluster around certain areas. You can see there, they are clustered on certain areas, here, here, here. Now knowing this, we can easily determine what is the cause of these kind of dysentery, and it has been found that there are polluted wells in these kind of locations. So then the civic bodies can take proper actions to take care of this kind of outbreaks. Well, you can see here even another example. Let us say there are three, very clearly the data is split into three different kind of clusters. Now the question is, how do you design an algorithm to find these three clusters? In your mind you have decided that you are going to make three clusters. In my mind I can even make more clusters. I can make one cluster here, one cluster there, one cluster there, one cluster here, one cluster here, another cluster there. So, there are 5, 6 different clusters, but you may say no, I want to have 3 different clusters, correct, instead of 6. Well, fine, you can do that, but how do you design an algorithm to do that? That is what we are going to discuss in the lecture today. So, as you clearly see here, these clusters here I am showing you, it can be easily put into 3 clusters. So, therefore, you need to have some clusters based analysis on the similarity of the data points. That means this method has to be defined in such way that we can divide the data into 3 different clusters. How do you do that? Well, the similarity can be based on simply the metric distance or Euclidean distance, cosine similarity, Manhattan distance, or even other kinds of similarities based on that. Okay. So, basically what we do, we can divide, we can find a similarity based on a metric like Euclidean distance, cosine similarity, or a Manhattan distance. Remember, I had given you about this distance things in case of KNN algorithm, and then you can actually put this point with the highest similarity score together. That is the simplest one to do, right? Very, very simple technique, but you have to measure distance. But let us also talk about what are different kind of clustering possible. Remember, there are 2 types of clusterings we generally do. One is a type of clustering which is known as a hard clustering. What is that? In this case, each data points belong to the cluster completely or not. Okay, we have clustering, but each data point is supposed to belong to a particular cluster. For example, let us say there are 4 data points and you have to cluster them into 2 clusters. So, each data points will belong to either cluster 1 or cluster 2. There is no data point which can belong to both. That is what is called hard cluster. Okay, we know hard work, same thing as a hard cluster. Now, in comparison, soft clusters are this: instead of assigning each data points to a separate cluster, the probability of likelihood or probability or likelihood of a point being a part of cluster is first evaluated. Let us say there are 4 data points and we have clustered them into 2 clusters, like the first case, like hard clustering exactly. But what we do, we evaluate the probability of a data point whether it is belonging to both clusters or not, and then this probability is calculated for all the data points. Then depending higher probability, the point is put to the cluster 1 or cluster type 2. But you can have probability same for the both cluster for a particular point. Let us say a particular data point has 0.5 probability for cluster 1 and 0.5 probability for cluster 2. This will belong to both. So, there is not like a hard and fast rule of putting a point to one cluster only. You can put the point to 2 clusters also, they can belong to. That is the difference between hard and the soft clustering. Basically, it means that in soft clustering, you can actually have option of one point belonging to 2 or more clusters. That is possible, because that is the belongingness is calculated based on the probability. Belonging is not calculated based on the any other parameters that. So, probability means you have a finite value less than 1, but it can have same probabilities for the one point belonging to 2 clusters, then it will belong to 2 separate clusters together. Now, the question is, what is the actual concept of clustering? So, let us talk about it. What is actually the clustering problem is? Suppose you have a given collection of unclassified objects or data. So, we have to find out a means to measure distance, it means of measuring the similarity of the objects, right. That is what is called distance metric. So, you can actually put any point whatever you like in the 2-dimensional plot and measure the distance of all the data points from that point, and then based on that you can draw a periphery. So, all the data points which are similar distances with respect to the central point which you have already placed will be part of that cluster. So, that is what it is. So, therefore, clusters or levels of objects such that some standard of quality is met, like maximize the similarity of objects. Basically, essentially it means an approach to discover a useful summary of the data. Basically, if you go down to the lemma approach, it basically tells you based on similarity whether you can find a means to discover a useful symmetry of the data. Ideally, we would like to represent clusters and with some semantic explanation also, but in mathematical terms this may not be very important. In mathematical terms, you have to calculate similarity based on certain distance metric. But when you do that, you have a problem. Problem is what? Problem is what is known as a dimensionality problem, and in the clustering literature it is known as a curse of dimensionality. While clustering looks in 2D actually very nice and nicely seen, I have shown you all these pictures, you can have seen that, but do you think it will be only 2-dimensional clusters? So you can have 3-dimensional, it can be higher dimensional possible based on type of data you have. So in that case you have multi-dimensional nature of the clustering comes. What I mean to say is that, so let us say I have, let me just put it in a particular way. So I have a 2D data points, right, I can easily clusters. Now in vis-a-vis I have a 3D, so then you have clusters. Remember this is a 3D, that is what we can draw in a Cartesian coordinates. So now what you would see that in 2D this is very easy to measure. Let us say I put a cross here, measure the distance of each point from this cross and do that, right, because it is only 2 dimension x, 1, y. 3D you have to measure distance of 3 x and y and g, right, from the data points. In 4D it will be 4 dimensional, 10D it will be 10 dimensional, but that is not easy. Sometimes hyperdimensional spaces will look very different, and the probability of random points being close to being close drops quickly as dimensionally to increase. That means probability of finding the close point when you place a centroid or some points like this cross in a high dimensional space is very low. So therefore sometimes problems cannot be solved, it will be very confusing. That is why this is good in 2D and maximum 3D. If you want to do it for high dimension, there will be lot of ifs and buts. So I gave an example high dimension case, let us not go back to it, you have already learned it. Now as you know, you have already learned what is that. So the clustering has 2 different kind of algorithms in a very layman approach. One is flat algorithm, it starts with a random partitioning, any random partitioning of data, and then you can refine it iteratively like K-mean clusterings or any other model based on clusterings will see that. You can also have, because this flat algorithm has its own problems, and that is why hierarchical algorithms are much widely used, because flat algorithm assumes certain clusters present a priori, the ones I shown you all the pictures. So it may not be the case for many of these actual data. So that is why you have to use hierarchical algorithms like bottom up or agglomerate kind of approach or top down or diverse kind of approach possible. Let us see how this will be. So first of all we can actually talk about 4 different types of clustering algorithms. One is called centroid based clustering algorithm, that is what is called partition based, and second is called density based clustering algorithm, which is called model based methods. Then you can have also hierarchical or connectivity based algorithms, and also you can have also distribution based clustering like a probability distributions. So let us talk about each of these. Centroid based clustering actually I have already discussed in the last lecture. So here this is the most easiest clustering algorithm. They group data point based on the closeness of the data points. Closeness means you put a point and then measure the distances. So generally this is measured based on certain distance, which is known as a Euclidean distance, Manhattan distance, Minkowski distance, and data points are separated into predetermined number of clusters, and each cluster is represented by a vector value. When compared to vector value, input data variables show no difference, and then we part it of a cluster. Okay, I hope this is very easy to understand. Now what is density? Density based clustering is a model based method, finds group based on the density of data points. So in the center based clustering we are talking about distance based, closeness data points using a distance. Here we are talking about density of data points. Contrary to centroid based clustering, which requires a number of clusters to be predetermined, and the sensitivity initialization, this clustering determines the number of clusters automatically, and is less susceptible to beginning with assuming something, and they are great at handling clusters of different sizes and forms, and they are very ideally suited for data sets with irregular separated overlapping clusters. So density based clustering, what we are talking about, it basically a mathematical model based. This is based on density of clusters. So there is no problem of measuring distances. So you do not have to assume any predetermined number of clusters like in case of centroid based clusterings. Okay. That is the advantage of that. Now, we can also have connectivity based clustering, or what we talked about, hierarchical clustering. This method of assembling the related data points into hierarchical cluster, like a tree like structure, right, family tree, and each data point is initially taken into account as a separate cluster. Remember, if we have n data points, we talk about each point as a one cluster, and then subsequently we will combine them. It is a very unique approach. Unlike in centroid clusters, we are assuming certain number of clusters, here we assume as many number of data points as many number of clusters. If n data points are present in your data sets, you assume n clusters. Then you subsequently combine these clusters that are more similar to form a one large cluster. That is what it is done, and then it forms a tree like structure, what is known as a dendron. Distribution clustering, using distribution clusterings, basically probability distribution, data points are generated and organized according to their propensity to fall into some probability distribution, like Gaussian distribution, binomial distributions, chi distribution with the data points. So, basically you are going to have some distribution functions by that way. So, normally we use centroid based and density based clustering, or hierarchical clustering more. Distribution based clustering is not so widely used in material science. So, now let us go back to what is k dimensional, what is k mean clustering. Okay, what is k mean clustering? Very simple. Okay, this is a process of teaching a computer to use any unlabeled, unclassified data and enable the algorithm to operate on the data without any supervision. So, it basically assigns data points to one of the k clusters depending on the distance of the center of the clusters. Okay, that is what it is. So, if I have to, let me go back to the board and discuss that aspects. Okay, so, if I have to talk about, let us say, this kind of data, one data, correct, then you have another data, another one, and this is another one. Okay. So, what do you do that? There are, we can see that there are 4 different types of clusters present apparently, but whether there are 4 or more than 4, that is what the questions I asked at the beginning also. So, what do you do? We put a centers, these are the centers, there is nothing like a predefined, you simply assume it at the beginning, then measure the distance from the center to these points. Now, based on the closeness, you can put all these data point into one cluster, right. Similarly, for this also, the closeness of the distance. If it does not happen, suppose these points are far away, then you have to define this is a cluster. That is what is called k mean clustering. So, now therefore, distance between 2 points are measured. Commonly once is what? That basically the distance we measure in coordinate geometry, x1 minus x2 square plus y1 minus y2 square divided by a root, actually take a root. You can also talk about Manhattan distance, or you can also talk about maximum distance, all are given here very nicely. So, let us talk about a little bit more on the board. Last time, let us take, we have n data points. What are they? x1, x2, x3, xn, right, small n. Now, k mean algorithm is aimed to divide these data points into k sets, S1, S2, S3, Sk, right. We divide the data point into k different sets, right, and in such way that we have an objective function j, basically is minimum of S, we want to make minimum number of sets, right. That is all you can do for good clustering. Summation I goes to 1 to n, right, 1 to k, not n, because k number of sets are there, right, remember this. And this x data points, they are belonging to S. So, x will go from 1 to n, right, because there are n data points only, but instead of that we write x belonging to the set S, right, any set. Then how do you do it? Very simply, we measure distance, absolute distance x minus mu y whole square, correct. And what is mu y? Mu y is nothing but the mean. Okay, this is the mean of data in any set Si. So, this can be modified actually. Remember, X is any data, correct. So, that is why X belong to S we said. Then any set Si, X will belong, that is why we have not put I subscript for the S. But mu I is basically mean of data in any set Si. So, this can be written basically minimum of S, then we can actually do summation better way, I goes to 1 to k So, what we did? We took the value of absolute value of Si, basically what we are doing is sum it over the value of Si and variance. Variance is nothing but a distance, right? Variance is calculated simply by distance, that is the statistical things, variance you know. So, V bar I bar Si is variance, that variance is also related to this x minus u mu I square. So, now this is your objective function. How to tackle it? How to tackle this objective function? Let us talk about it. It will not take much time to discuss because we have discussed in last lecture. So, I just remove this part and discuss about it. Well, in order to solve this problem, we have to introduce a new variable that is known as R and K. What is that? It is convenient to define as new variable R and K, okay, assigned for the data points. If you want to assign data points, assignment of data points to each cluster. To each cluster, that is why you have to do. Basically, it will help mathematically to solve this problem. So, what we do? We define R and K, it has two values only, 0 and 1. It is nothing but a binary indicator. Okay, this is a binary indicator. Why it is called a binary? Because it has two values only. Am I clear? That is what it is. It is a binary indicator. It describes which of these k sets, there are so many k sets, a data point is going to belong. So, R and K is going to be equal to 1 if j is equal to k, is going to 0 if j not equal to k, correct. That is what it is. If a data point belong to a particular k set, then R and K will be 1. If it does not belong, it will be 0. That is very simple. If it does not belong, then there is no point in calculating this objective function. So, that is why it can simplify our whole mathematical analysis for this objective functions. So, now we can write down j, okay, let me take out this, we can write down j, with this knowledge you can write down j is equal to, very simple, sum it over I one to n, sum it over k 1 to k, R and K x I mu k whole square. That is it, right. So, you can clearly see all these problems of variance S, everything is vanished just by putting this particular binary indicator. Well, when the binary indicator 1, then only this sum is required. If the binary indicator is 0, then sum is 0. Am I clear? Now, once you have this function, So, that means what? This indicates the squares of the distances of each data points to its assigned vector mu I. Squares of distance of each data points xi to its assigned vector mu k. Remember that, I just shown you this. If I have data point like this, I put any arbitrary center. So, this tells you the squares of the distance of this data point, let us say this data point, this one, to this distance, okay. Or if I zoom it up, this distance, that is what it tells about squares of the distance of that, correct, xi minus mu k. Mu k is one cluster, for that cluster mu is the mean value. So, now what is the goal? Goal is to find out both mu k and Rn k, right. How to do that? That is what we have to discuss, correct. So, let us do it quickly. This is very simple maths, not very difficult. So, first of all, J is a linear function of Rn k. You clearly see, right. Rn k 1, Rn k 0, there are two values of Rn k possible, but whatever it is a linear function of Rn k. If it is a linear function of Rn k, we can adopt an optimization very easily. The terms involving different a's, different n's actually, terms involving different n is n, okay. So, this should be small n because we are using x small n. So, terms involving different n are independent, okay. Different n's are independent, they are not dependent on each other. Remember this. Why it is called independent? Because for each cluster k, for each set or cluster k, these n's are independent, they are not dependent on each other. So, therefore, we can write down Rn k is 1 if we have already done that, k is minimum j x k minus mu j whole square. If the distance is minimum, then Rn k becomes 1, that point becomes to that set. If it is 0, 0 otherwise. That is very simple. Since a linear function, we can do this. So, what it does, it calculates distance, correct, calculate distance between that. So, or rather I think I have made a mistake, it should be this, k should be here, okay. So, for any point j, the distance between that point and the mean of the cluster, square of that distance should be minimum. Then it is done, then it is part of the cluster. So, the Rn k become 1. That is very easy. So, we can actually choose 1 for value of k that provides this minimum distance, okay. Otherwise, it has become 1. So, that is the way to find out Rn k. So, first we find out Rn k, this is my first job, first target. Second thing will be to find out the mu k, right. How do I do that? Well, very simple, you can see J is a quadratic equation, quadratically connected with mu k. So, that means if I want to find out mu k, I have to take this derivative and put it 0, correct, and this derivative is equal to what? Obviously, this derivative will be 2 will come out, 2 is not a variable, and 2, then you can clearly see this is n equal to 1 to n Rn k, then we can write down x n minus, we are using less I actually, x I minus mu k, that will be equal to 0, because the first derivative, since we want to minimize the j, that is why it is. Obviously, these two values will be selected in such a way that j objective function will be minimized. That is a principle for any machine learning approach. So, you can clearly see if you do the math properly, mu k is basically what? This one. So, sum over 2 will get cancelled anyway. So, this is what is going to be 0, sum of n Rn k x I divided by summate of Rn k n. So, we put n here, n goes basically is I 1 to n. So, that is what it is. So, that is how based on these two the equations the whole algorithm operates. So, all the programming which we will do based on this equation. So, this is the fundamental concept of the k mean square algorithm or whatever you talked about it. But you can see the denominator of this equation at the bottom, number 2 is what? It is basically equal to number of points assigned to a cluster k. Yes, number of points, this Rn k is basically summation of Rn k is 1. So, this is basically summation of the data points which belong to k, any set k. So, that is what it is done. So, let me stop here, although we have taken a little more time, come back to the next part of the lecture which we talk about hierarchical clustering, okay, and soon.